Let's get started. My name is Gang Shu. I'm the field application engineer in Bosch Sensortec. I joined the Bosch for 7 years. Right? Yeah. Before I have had a lot of experience in MEMS sensors applications. So today we're going to talk about agendas like who we are, what we do, and what we can offer for smart home. Right. So we are Bosch. Many people know Bosch from like dishwasher, right? Power tools, yeah. And Bosch is a big company, more than 130 years old, private company, over 400,000 employees worldwide. It's a huge company, and Bosch is famous at the quality for all the products. The most business from Bosch is automotive, right? Like Mercedes, Audi, BMW, those vehicle control system, made by Bosch. Right. So we are the most trusted provider of innovations, innovative sensing solutions that improve our well-being and lifestyle. So Bosch Sensortec is a subsidiary of Bosch Automotive Division. Okay, so we only make consumer electronics MEMS sensors, like motion sensors, environmental sensors, and also later the optical sensor, right? Like PM2.5, right? Micro mirror, those optical sensors. So we started making MEMS sensors from 1995. We have shipped over 10 billion sensors so far to the market. And also we have 100% in-house technology. And we make like a sensor roadmap so other competitors just follow our standard. Okay, we have also global support in like logistic engineering, and in Germany, in China, in India, which is a global company, right? So we have recently built a new fab, 12-inch fab, somewhere. We don't have a capacity issue. Every day we make 3 or 4 million sensors, right? Right, 10 billion superheroes in chip format. Okay. So here we have MEMS sensors. You can see, automotive, this area for vehicles, and Internet of Things, and the consumer electronics, including gyroscope, IMUs, accelerometer and gyro combo chip, magnetometers, right? Pressure sensor, gas sensor, humidity sensor. So we make all these sensors. This slide just shows that over 3 years, from 2016, 17, 18, Bosch Sensortec is #1, most revenue. This is a combination of automotive grade MEMS sensors and also consumer grade MEMS sensors, right? #1, Bosch, and followed by ST, TDK, NXP, analog device somewhere. So those are our competitors. So what do we do? Here you can see the whole Bosch sensors that we make here. Motion sensors, like standalone accelerometer, gyro, magnetometer. So our naming is easy to remember. BM, Bosch MEMS. A means accelerometer, G means gyroscope, M means magnetometer. So BMA, BMG, BMM, all right? Then IMU is BMI. IMU is accelerometer and a gyro combo chip. BMX It's a 9-axis, so all in one, right? Accelerometer, gyro, magnetometer, 9-axis sensors. So this is a motion sensors. Then we have environmental sensor, BMP for pressure sensor, BME for environmental sensor, humidity. Right. So this is a gas sensor, 4-in-1, BME680. This is a BME280, 3-in-1, temperature, pressure, humidity. This is BMP388 for temperature and pressure. Right. Then we have another family is called smart sensors, meaning that inside this sensor chip, for example, BHI, hub, IMU hub accelerometer, BHI, it has IMU inside, 32-bit floating point, ultra-low current microcontroller inside. It also has our Bosch Sensortec proprietary sensor fusion algorithm running inside. So it's a smart sensor hub. It has two interfaces. The primary interface, SPI or S2C, talk to the host processor, and the secondary interface, I2C SPI, taking care of external sensors like a proximity sensor, pressure sensor, magnetometer, all kind of sensors. So this smart sensor hub is programmable. You can use your own ECG sensor or PPG sensor, develop your own driver for the smart sensor. Then it will output all the results directly to the host processor. So your host processor doesn't need to take care of those external sensors, right? Just focus on the main tasks. The hub will take care of all the external sensors, right? We have another sensor, BNO. It's all-in-one sensor with Atmel microcontroller inside, right? So this one, the difference between these two is after power on, BNO 055 is ready to go. Just give a command. Give me 9-axis sensor fusion results. Just one command. I2C, it will, here you go, 100 Hertz fixed sensor fusion output, right? Results like quaternions, unit angles, pitch, roll, and heading, and linear acceleration, gravity vector, ready to go. But for BHA smart sensor hub, every time you power on, you need to download the RAM patch because the microcontroller inside needs an instruction set. Okay, give me the instruction set. Then later you can enable different virtual sensors. For example, rotation vector, linear acceleration, different virtual sensor. Then it will output sensor fusion results up to 200 Hertz. Right, the latest hub can output up to 800 Hertz, give you the results. Sensor fusion running here. The last one is the optical microsystem. So far, it's not ready yet in the market. So basically, we have a interactive projection module, which means it project the image on any surface, focus-free. Very clear, doesn't matter how far, focus free. And then you can tap the buttons on any table or surface, then it will recognize and take a reaction. So this is an interactive projector. For example, if you project a piano on the table, then you can play piano, right? Doesn't need to have a real one, right? So this is not ready yet in the market. Then the software I mentioned for sensor fusion, it's inside here and here. We have our own in-house sensor fusion algorithm software. And for BME680 gas sensor, 4-in-1 gas sensor, we have BSEC library, BSEC library, Bosch Sensortec Environmental Cluster, available to download online. BSEC software. So we have all different packages. For example, Cortex M4, Cortex M3, and Arduino, 16-bit microcontroller. So you can find all the packages there. Then you can integrate it to your own firmware. Then you can get output BSEC library, which is ECO2, equivalent carbon, CO2, right? Dioxide in the unit of ppm, and also total VOC concentration in the unit of ppm, right? Also, BSEC library can output indoor air quality IAQ index, 0 to 50, excellent. 51 to 100, good. 101 to 150, some average. So later you will see something there. So this slide just shows all the sensors we make, okay? Yeah. In details, we have part numbers now here, right? BME280, BME680, BMP388, right? And also smart sensor hubs, BHI260, this brand new 800 hertz output rate, sampling rate. It's not in the market yet, but it's in mass production, not in distributors yet, okay? Right, all the part numbers here, easy to recognize. BMI, this is our latest 270. It's a accelerometer and the gyroscope combo chip, data synchronized inside by design, ASIC design. And also it has, component retrimming feature, CRT, we call CRT feature. So after soldering, the gyro sensitivity may change due to the mechanical stress. So we have CRT feature to compensate it, to make sure the sensitivity is within 0.4%, plus or minus 0.4%, the gyro sensitivity. For example, if you spin at 100 degree per second, so that one will be 0.4 degree per second error. So sensitivity, we have this new feature. And then you can see all the parts are available in distributors like Future, Aero, what else? Future Aero, Mauser, Future Aero, Mauser, DigiKey. Yeah. Oh yeah, DigiKey, right. Yes, thank you. So these all the sensors we make, okay, here. Then what can we do for smart homes, in smart homes? So we have those sensors, you can see, can be used in the smartphones, tablets, wearable, hearable devices, augmented reality and virtual reality, drones and robots like vacuum cleaners, and a smart home, gaming and the toys, right? So there are IoT applications for our sensors. Then back to smart home. So there are three categories for smart home. One is efficiency, energy efficiency, and comfort, like well-being, right? And safety, anti-tamper or some intrusion detection. So these three categories, right? For each category, we have sensors for this such a use application. For example, BMA400 is our latest brand new ultra-low current accelerometer, 3-axis, 12-bit, 2x2 by 1 millimeter. So it consumes 850 nanoamps for motion detection. If the window is open and the door is open, it can give interrupt to the host processor. Hey, something happened, motion detecting, right? BMA400, it's 2x2 by 1 millimeter. So here, this slide just shows the block diagram of the application and the main key parameters for BMA400, right? below 1 microamps at 25 hertz. This is low power mode using duty cycling, just sample, sleep, duty cycling. However, when working at normal mode, it consumes 3.5 microamps. Continuous mode, no duty cycling. So that means there's no aliasing issue, So the BMA400 has no aliasing issue. It's continuous sampling at 3.5 microamps. Yeah, very low current. But if you want to put in low power mode, 25 hertz fixed sampling rate, it's using duty cycling, okay? Yeah, for motion detection, saving power. So this is the main parameters for BMA400, 2x2x1, right? It's better than other competitors' accelerometers in the market currently. It also has other features like significant motion interrupt. It also has a step counter built in, right? So you don't need to develop your own step counter. It's inside. Yeah, how many steps you have worked. BMA400 can output the step counters, right? Then for the indoor air quality, we have application BME680 4-in-1. BME680 4-in-1, temperature, pressure, humidity, and VOC gas sensor all in one, 3x3 by 1 millimeter package. So this BME680 can be used in smart home for like a smart vent, a kitchen hood, right, and a personal weather station, and also smartphone cover, right. So we have a customer developed a smartphone cover like for battery, memory, and also BME680, right? So you can always know the indoor air quality everywhere. So for the VOC gas sensor, this slide just to show that it's very important for human beings' health, right? Because we breathe more than 10,000 times per day. And also we spend 1/3 of life in the sleeping rooms. And also we stay 90% in buildings, indoor, right? So it's very important for our health. We need to know if the air quality is good or not, right? So VOC stands for volatile organic compounds, right? It contains thousands of different gases, right? Formaldehyde, acetone, ethanol, right? Carbon monoxide. So this is very important. With CO2 is not that important as the human breath, for the health, right? So we need to know VOCs. Here's the definition of VOCs. You can see many different. So BME680 can detect nearly all VOCs and gases in our air. However, it doesn't know which is which, Yeah, it's all these VOC. I don't know which is which. So this sensor is measuring all VOCs. However, Bosch is an innovative company. We spend a lot of money in R&D, right? So we are developing a new BME688 new gas sensors. From hardware point of view, it's the same BME680. However, from the software view, we are developing artificial intelligence machine learning software so that BME688 can detect specific gas in the room. For example, newly painted room, or you just purchased the new furniture, the paint, so the BME688 can detect if there's a formaldehyde, right? How strong it is, right? If someone has a winter time, you burn some heating stuff, right? So BME688 also can detect if there's a carbon monoxide in the room. Just give you warning, hey, please open the window, right? So it will be a selective gas sensor for BME688. Here, this slide just shows BME680 looks like this. It's a metal lid. Here, temperature, humidity, pressure, and the gas, 4-in-1 combo sensor inside this chip. So the gas sensor is based on MOX, metal oxide technology. There is a special coating. There is a special chemical, coating on the heat plate. So every time when you do a measurement, you need to heat up the plate to 300 degrees Celsius. Yeah, between 200 to 400 degrees Celsius, heat up the heat plate. The duration is 100 milliseconds. The duration is 100 milliseconds. So very short time. There's no heat, huge heat on the lid. It's still very not hot. Okay, the sensor itself, right? So then after the heat plate, you control the resistor to heat up the plate. Then the chemical reaction will happen. If the VOC is detected, then the raw resistance will drop significantly. So we measure the resistance. So our BSEC library just use temperature data, humidity data, and the gas data to calculate the indoor air quality, the algorithm, right? Pressure sensor is not used for indoor air quality. This slide shows our accuracy, how good it is, for IAQ, indoor air quality accuracy. It's a plus minus 15%, plus minus 15. In the datasheet, we have this plot to show the the accuracy, right? Indoor, you can see here, excellent, good, lightly polluted, moderately polluted, heavily polluted, severely polluting, over 300. So some customers ask me, hey, what if we more than 300, what should I do? Run away? I said, no, don't run away. You just open the window, just give you a warning. It's not that critical, don't run away, right? Okay, so another application for smart home is the HVAC control in the buildings. We have this reference design block diagram, and we use two sensors, BME680, BMA400. We just introduced these two sensors, right, for smart home speaker, like thermostat, right, thermostat speaker, and also for some LED lighting, smart lighting. So everything you can think of in the room, right? You can use these two sensors for the new design, right? So this is another application for kitchen hood. You use BME680 to measure the smoke if something is burning, right? The food is burning, give you an alarm, right? Then refrigerator, you can use BME680 to detect some food is rotting or becoming bad. So you need to change, right? So this is the design and also the sensor used here, BME680. Some food, detection. We have seen another application for a washing machine using a BMP388 pressure sensor for water level detection, right? So, these sensors, BMA456 accelerometer, BMI270 IMU can be used for vibration detection, right? And dynamic measurement of acceleration, angular velocity, and adjust speed rotation, right? BMP388 for water, level measurement. So this is another use case. Then for BMI270, we already introduced a little bit our brand new IMU, 3 by 2.5 by 0.8 millimeter package, right? It's low current with CRT feature, low current below 700 microamps, which is actually 685 microamps when both accelerometer and gyro are operating in full speed, normal mode, right? So this device can be used in a wearable fitness, those kind of applications. Then BMP388 is also our new pressure sensor, high performance. Yeah, the relative accuracy is about plus or minus 0.08 H-Pascal, and the absolute accuracy is plus or minus 0.5 H-Pascal. It's 2 times better than the previous one, BMP388 pressure sensor, right? So absolute accuracy plus or minus 0.5 H-Pascal corresponds to plus or minus 4 meters about the sea level. Reference is the sea level. So which means if you solder thousands of BMP388 on your PCB, everyone should tell you the pressure, measure the pressure within plus or minus 0.5 H-Pascal, in this range. Absolute accuracy, right? Relative accuracy means each individual pressure sensor, if you go down through the elevator, that accuracy, right? 0.068 H-Pascal stands for like 50 centimeter, 60 centimeter accuracy, right? If you go above to 10th floor, the accuracy is very, very good. Yeah, so if you call E911 from your smartphone, it will tell you exactly where you are. The firefighters can find you quickly, which floor. Right. So then there's another application area, is a vacuum cleaner. Yeah, so for smart home, we have seen these products, right, in the market. So we have BMI088 new sensor, new IMU, especially for robot drones applications. So BMI088 includes our closed loop gyro. Closed loop gyro means it has a feedback loop inside the gyro to make sure the oscillating frequency is maintained, stable. Over the temperature, it doesn't change. Over the vibration, it doesn't change. So it's closed loop gyro, our best performance gyro in the market so far. And then the accelerometer part is a 16-bit accelerometer, high accuracy accelerometer. So this is a combo chip. However, this combo chip is not like a BMI270. Accelerometer data and the gyro data are synchronized. So the accelerometer and the gyro inside the BMI088, they are independent. They don't talk to each other. They run at their own sampling rate. But we have a way to do externally data synchronization. Yeah, we have an app note for it. If you need really data synchronization, accelerometer and the gyro, we have an application note how to do it externally, okay? So for the robotics, here you can see this is the reference design diagram, and the sensor can be used for this application, right? BMI088, BMM150 is the magnetometer, just to tell you where you are facing, right? Facing north or facing west, south. And then also the indoor air quality BME680 can be used here, right? BMI088, another feature is excellent vibration robustness and suppression. The accelerometer part, we have added damping feature inside the MEMS, accelerometer MEMS, which means when the robot is spinning, is running, the vibration will not affect accelerometer's measurements, right? So we have a robustness for MEMS accelerometer, right? We have very stable, large temperature changes, very stable. When it's getting hot inside the robot, the gyro data offset doesn't change too much, okay? Here is the use case table, just to show if you are working on different applications, which sensors can be used, right? This is optional. This is for sure, right? Can be used for different applications, right? Like asset tracking, like fitness, like hearable devices. Yeah, this table gives you the options for the sensors. So for BME680 smart home, we have seen a new design win in a Xiaomi concept for smartphone, BME680. This is our, most recent design win. They use this BME680 to detect the indoor air quality, BME680. Another use case is for hotel room vacuum cleaner, right? So hotel room, there's some a dog, cat urine on the carpet. So the vacuum cleaner can tell the hotel clean mate, hey, please pay attention. This area we detected some animal urine. So BME680 is useful, for this application. Another BME680 application is like a smart mask, right? Smart mask. So when you go outside, you can know the air quality, and then you turn on the filter or not. It's a smart mask. It's not a regular mask. It's a small device for air quality. And also recently, Bosch Sensortec is developing PM2.5 sensor, right, based on laser technology. It's not a MEMS technology, it's a laser, just to measure the particles in front of the laser, PM2.5. Yeah, we can output micro G per cubic meter, that unit for the concentration. So actually, Bosch is an innovative company and invented for life. We always spend a lot of money on R&D, new technology, new sensor development, right?